board member of the National Space Society, and I have the privilege of being your representative here to introduce your speakers and recognize questions from the floor and so on for this presentation. Today, to talk about undersea habitats as an analog for space habitats, we have Dennis Chamberland and Scott Carpenter. Dennis Chamberland is the director of the League of the New Worlds and is a bioenvironmental engineer. He specializes in life support systems. He's an active aquanaut, completed 8 seafloor missions, including the first ever planting and harvesting of agricultural crops in a habitat on the ocean floor. Dennis is the writer of over 100 articles and a novel. He is the designer of 4 seafloor habitats: the Challenger Station, the ER-1, the EPOD-1, and the Scott Carpenter Station. So he can tell you a little bit about his plan, and then we'll let Dennis introduce Scott Carpenter.
Good morning. Morning. Can I see some smiles out there this morning? Okay, that's much better, much better. This is a great day, really. If you remember, how many of you were alive 35 years ago? Okay, great. You remember where you were 35 years ago tomorrow? I do. I was sitting in front of it. I was on the plains of Oklahoma, sitting in front of the television about this big little black and white thing, and watching this gentleman climb on top of an ICBM. That was an amazing thing to me at the time. It still is an amazing thing to me. And it's my privilege to be able to introduce him to you this morning. As you know, as soon as he got down off of that rocket, he went into the Sea Lab program and began to investigate exploration activities underwater. I just also want to say, before I allow him to come up here, that he is a wonderful individual as a human being. I've known many astronauts over the years, and I think Scott is absolutely at the top of the list. I'll give you one example. I called him up one day and told him that I was working on an underwater project, and he is very, very supportive of these kinds of things. And Scott said, this is a true story, he said, "What can I do for you?" And I said, "Well, I need somebody to help me get through the bureaucratic maze up in Washington." And Scott got on an airplane and on his own time and on his own money, he went and spent the day in Washington, D.C. to help me out with my project. And that's the kind of individual he is, a wonderful human being and a great explorer. So Scott Carpenter.
Thank you, and good morning, ladies and gentlemen. I've been given about 15 minutes, I'll try and keep it below 10, to explain to you a little bit about the analog that Dennis and I both see between work in the ocean and work in space and exploration in both of these environments. I want to give you a few motivations of my own because they prove the value of serendipity, and I've had a life that has strangely enough been filled with serendipity. I was born in a high country in Colorado and had no association with the ocean whatsoever. I joined the Navy. That got me a little bit closer to the ocean. My first duty station after I got my wings as a naval aviator was Hawaii. And I lived close to a couple of little Hawaiian boys who took me spearfishing, and I was hooked by the coral reef and the underwater life. Even before that, I think I had been intellectually challenged and fascinated by The Silent World, Cousteau's first book, and I was further hooked. I carried that fascination. No, there's another important issue here. Part of the serendipity in my life comes from a knowledge that I accrued over my experiences that conquering a fear is one of life's, if not life's, greatest pleasures. We, in the course of our training in Hawaii, were in the middle of a survival exercise where we had a big airplane with a crew of 10. And we were put in the water and told to simulate a ditching. How are you going to survive at sea if you ditch and get out and all you've got is 3 life rafts and 10 men? My gunner's mate was in the raft with me, and we were just getting everything all ship-shape, ready to wait for the ship to come pick us up. And our corner reflector, which is sort of a orthogonal set of wires in mesh, it reflects a radar signal from any direction, and it is probably the most important piece of gear you have on the life raft if you want to get found. In rigging that corner reflector, it went over the side of the raft, and the gunner's mate, and I looked at it there, and I realized at that time an unreasoned fear of the deep ocean and the critters that live down there, and I didn't go after that corner reflector. But my gunner's mate did, and he brought it back. And I thought that's about the bravest thing I ever saw anybody do, because of this unreasoned fear I have had at the time for the deep blue ocean. And I'm very uncomfortable with unreasoned fear. So that now segue into the NASA program, where I was instrumental. Because of that fear, I instigated scuba training for the first group, and that continued through all the other groups that came. As far as I know, it's still being done today. After I flew, I continued to read what Cousteau had done. I continued to be uncomfortable with this unreasoned fear. I began to see that there was a chance to transfer some of the highly funded, handsomely funded NASA technology to turn it to use in what Cousteau was currently doing with his con-shelf experiments. I went to see him when he was speaking at MIT, introduced myself and told him I'd like to come to work for him, and I could bring with me some NASA technology and some NASA consulting and other supportive work that I thought would be helpful. There would be a good transfer of technology between the two. It's quite so. Dennis will speak to you, I think, about that. I met all his divers, including a principal fellow, his younger son Philippe, who is no longer with us, and enjoyed the encounter very much, but Gilles told me that he couldn't pay me very much, and I didn't speak the right language. But he thought it was a good idea to try and transfer the technology. He said, if that's what you want to do, why don't you do it with your own Navy's program? And that's how I found out about CLAB and met George Bond, the father. You may not know this, but the concept of saturation diving belongs to your United States Navy. It was all conceived in New London by Navy Captain George Bond. That's reason for celebration. In any event, I got involved with the Navy program, thoroughly enjoyed it. And for me, personally, the fact that through that program I was able to conquer this unreasoned fear I had of the deep ocean, that was very important to me. We didn't know much about sharks in those days. I'll have to tell you that story too. We know more about sharks now than we did then. There was a lot of unreasoned fear. In the early days, NASA had picked up a few of their unmanned capsules in the Caribbean with evidence of shark attack. One phenolic heat shield had a shark tooth embedded in it. So NASA launched a highly, handsomely, again, paid development of an electronic shark chaser. When we were worried in Sea Lab about sharks too, we had unreasoned fear, and I had known about this development. I was currently training with fellows in Panama City, wrote my boss at NASA and said, would you send this electronic shark chaser to a Navy consultant fellow at the Marine Laboratory, Perry Gilbert, shark expert. The one model of the shark chaser was sent forthwith to Perry Gilbert. He evaluated it for about a month in his shark pen, sent it back to NASA in Houston with an evaluation letter to my boss and a copy to me. I'll paraphrase the letter, but it said essentially, gentlemen, we have evaluated. I got to tell you what this thing looks like. You can assume it's a cylinder, a sphere, stainless steel sphere, with an on-off switch, which is actuated when it is ejected from the spacecraft as it lands on the water. So it's pushed out, the on-off switch goes on, some extendable antenna go out, and it is supposed to emit electromagnetic and sonic signals that frighten away the shark. So Perry wrote, as I said, my boss, when a copy of the letter came to me, and it said, gentlemen, we have evaluated your electronic shark chaser and find it mildly repellent to our sharks in both the on and off position. NASA canceled forthwith the development of that shark chaser, and to date we still don't have a very good way of frightening away sharks. Although there is a new one on the market that scuba divers are working with, and it might be effective. The jury is not in yet. Back to the technology transfer. First of all, the technology that came from space to the ocean came mainly because the ocean, the people who work in the ocean don't have much money. It's not the glorious pursuit that is spaceflight. We have, because of that money, been able to outwit space, and there are a lot of stressful things, a lot of unknowns in spaceflight, but we have outwitted a lot of those difficulties because we were so handsomely funded, and that's because it is such a glorious pursuit. Doesn't pertain to the ocean. We were never well funded with greenbacks or with talent because we didn't have the money to pay the talent. And so in order to get along in that environment without the money to outwit it with technology, we overpowered the ocean with heavy iron, and that leaves the poor divers with a lot of heavy iron to move around. The work in the ocean is mule hard. It is bitter cold. You don't see very far. You don't have really reliable and well-tested equipment. And so there is a lot of hard work and some risk involved in ocean work that is not to be found in space. But the technology for developing that equipment was transferred from space to the ocean, to the benefit of all of the Navy and civilian divers in the 3 Sea Lab programs. I like to think that I was least effective in bringing about that transfer of technology. It continues a little bit today with what Dennis is doing, and there is a great similarity between the stresses, the isolation, confinement, other psychological stresses to be found, but there is great technology transfer potential, and more of it will come to pass as time goes on. Dennis will see to that, I'm sure. And I think that brings me about to the end of what I wanted to tell you about my involvement. It's one that is a direct outgrowth of serendipity and an awareness that conquering a fear is a very important thing in one's life. I think that does it. I thank you for your attention, and stay tuned because we're going to do some more serendipitous things in the ocean that will not only improve our lot, but improve a lot of our spacemen. Thanks.
I'd like to review a couple of things real quickly with you after that discussion. Would you turn that? Do we have any, we dim the lights here, please? Just a little better. No, we can't. Okay, there we go. I wanted to show you this picture first off, now for a couple of reasons. This picture was done by Robert McCall. It shows a hypothetical lunar base. It's just beautiful. You can see these wide windows. You can look outside and see the lunar landscape. It's just wide and spacious, and it's a wonderful place to be, don't you think? Robert's daughter is standing at that table right out behind us there. I thought that was kind of interesting. We should have that kind of a contrast. But let me show you what reality is about. Okay, Robert is the best artist in the business. There's no question about that. And this is a wonderful picture. But let me show you reality here. This is reality. This is your real lunar outpost, and notice where it is. Where is it? It's under the soil. It's not soil, but it's under the regolith of the moon. And that's what you're really going to find when you go out to the lunar base and the Mars bases. You'll see things like this. You'll find structures that are covered up with the lunar soil as radiation protection. So what we do, when we take a reality check and look into space, we look at what we're really going to find rather than what we would like to find. And one of the things that we can do as we look out across our planet is see places that we can practice for the moon or for Mars or for space exploration. And one of those places that's a great place to go practice is the oceans. And that's one of the things that Scott represents. He was able to go out in Sea Lab and do the Sea Lab experiments. And those were really great analogs for space exploration, because where do the humans live? Do they live outside in the vacuum of space? No. They live in space capsules, and they live in modules that we can duplicate almost exactly in a remote and extreme environment that we call the oceans. Now, in reference to that, if we go out there to the oceans and we begin to develop these space analogs, what else can we use them for? We can use them to populate the oceans themselves, and that becomes kind of a reverse spin-off as we look at out into the future of space exploration and developing our space analogs in the ocean. This is a good example of a real habitat that goes underwater. As a matter of fact, this morning as we talk, there are only 2 habitats that are actually operational and in the water. There's one that I'm not counting that's in dry dock right now, being refurbished. That's the Aquarius. But right now, there are only 2 operational underwater habitats in the world. This is one of them out of the Marine Resources Development Foundation in Key Largo. And if you look at this particular slide, you'll see some crew members inside of a command module. Where do you think that this sketch was taken of? A space habitat or an ocean habitat? Any guesses? Actually, the point is that it doesn't matter, because you can make your space habitat and your ocean habitat exactly the same. You would not be able to tell by looking at the interior whether there was a difference or not. Now, why would we want to go do that? Well, the answer to that question is cost savings. If we take this device up into orbit, it's going to cost us right now something like $2,500 to $3,000 per pound to get it into low Earth orbit. If we took a gallon of water, let's say, to the moon to drink, given today's technology, that gallon of water would cost you about $500,000. So if you look at the oceans, you can find a remote and extreme environment that is a perfect laboratory to take these modules and test them before you actually commit them to the space environment. And that's really what an ocean analog is all about. It's practicing underwater for these kinds of modules that we are actually going to take up into orbit. This is a good example of a photograph or an artist's rendition of something that we hope will be. This is an actual photograph of an underwater habitat that has been used by NASA before for different kinds of space studies. And of course, some of the questions that we want to find out when we get there into these ocean and space habitats is how are we going to breathe, how are we going to eat, what kind of advanced life support systems can we have that will actually do the trick. This is a picture of an actual underwater habitat. This is the second operational habitat, the Jules habitat out of Key Largo. Could you think you could spend some time here? Spend a lot of time here. This thing has a refrigerator, it has a television, it has a VCR. We're talking luxury here, folks. We can have this kind of thing either in the space or the ocean environment. And the ocean is a great place to go test these habitability issues. There's a friend of mine, Rick Presley, stayed in this thing for 69 days. It was the longest undersea mission ever. And when Rick had to go, the only reason he left was because they ran him off. His mission was over. It was time to go home. Rick, please leave. Right, Mark? Am I telling the truth? He didn't want to go because he could have stayed here many days longer. The reason for that is the habitability of this place is very high. And these are the kinds of things that we can understand in the oceans before we actually commit these pieces of hardware to space. This is just another example of a lunar base concept. You can imagine that if we establish this base on the ocean floor, it might cost, say, $500 million. If you establish the same base on the moon, it's going to cost you 10 to 100 times more than that, so that we can understand the expensive issues before we actually commit them to the space environment. This is just a module example of an advanced underwater habitat that could also be used on another planet. Now, as we look out to Mars, I saved this slide to last, we look at all kinds of issues. We look at advanced life support issues. You know that when our spacecraft set off from Mars, that it's a no turnaround trip, it's a no abort trip. Once we commit to those interplanetary orbits, we are there for the duration of our mission. We cannot afford a loss, we cannot afford an accident, and some of those things that we can learn on the ocean floor will probably save the lives of our astronauts in the long run. Let me have the lights back on now. Now, as we begin to look at these issues, I want you to remember that this paper is available in a written form in your proceedings, and you'll be able to read about this in detail. Of course, we go into it in much greater detail than we could at a presentation like this. Across the hall at the League of the New Worlds table, we have more books available that Scott has autographed. After this meeting, he is going to have to leave directly to make his appointment at the Kennedy Space Center, so he will not have time to do the autograph. So we ask him to autograph the books in advance for you. At this time, we have time for several questions. Scott, you want to come on up and help me take these, please? Yes.
I'd like to just question against that Carpenter. 35 years ago today, this very day, you were going to board Aurora 7 the next day and blast off. Did you have any apprehension about this?
There is always apprehension, and believe it or not, there is always fear. And there, you know, Roosevelt was wrong when he said the only thing we have to fear is fear itself. Fear is not to be feared, in my experience. Fear is a God-given gift that helps you do your work better. And it's a vital cockpit companion, clinically provable to make you see better, improve your endurance and your vision and your strength, reduce reaction time, it does all sorts of good things. So yes, there was apprehension, there was fear, and that's a good thing. Yeah, okay.
This Jules habitat was probably designed for shallow water. Is there any pressure relation to the pressure on space capsule would have?
The Jules is actually designed to be an ambient pressure habitat. It was designed to operate at 120 feet. So it was really, in terms of habitats, it's a high pressure habitat, and it only has an analogy to space in terms of its habitability issues and its potential application in terms of advanced life support hookups.
I think it's important to realize that a habitat like this has no pressure differential. If the pressure inside is always equal to the outside, so that a pressurized habitat is designed for any depth.
The gentleman who stayed 16 days, that's a single person habitat, so he stayed alone the whole time?
No, it's a very large habitat. It can probably take up to 8 people. So there were a lot of people in and out of there.
Okay. Yes, sir.
To what extent is a lot of this being driven by companies such as the oil companies who work on the deep sea drilling platforms, etc.?
Well, let's see. I don't know. I think this was all inspired originally by my curiosity. But once the capability was developed, then the oil patch people began to utilize it. I don't know that it was part of the inspiration, but it sure did use the aftermath.
Yes, sir.
If this is a less expensive way to pioneer space habitat development, why is there a funding problem, and how can we be more successful in getting financial support?
Well, we don't have any funding problems with using not the ocean, but at least water for simulating space, EVA, and other space activity. But if you talk about exploring the ocean, there doesn't seem to be, for the moment, a return on the investment. Only if, depending on how you value the satisfaction of your curiosity.
We have time for one more question. Yes, sir.
Do you think space or the ocean floor should be the next great frontier for human settlement?
I feel like the answer to that question is yes.
Both at the same time?
I think both at the same time, absolutely. I don't think there's any reason to favor one over the other. I see a lot of favoritism towards space, and frankly, I don't understand that. Call me weird, I don't know. But I don't understand why there's a favoritism of space over the ocean. Both environments are incredibly exciting, incredibly beautiful. There is tremendous potential for permanent human habitation of the seafloor frontier. And I'm just, in one way, I'm kind of happy. That has allowed my group to step in where there was nothing in a void and take some action in an area where nothing had been done. That's positive for us. But I don't understand it. I think one day that there will be a breakthrough. Probably the reason that there is not, in answer to the other gentleman's question, sir, probably the reason the funding isn't there is that there just hasn't been enough education in the area. And it's groups like this, it's opportunities like this that allow us who enjoy thinking about those concepts to tell you about it and go forth from there. There's one. I can take one more question. Yes.
No, I was going to say one area that I'm surprised where no one's talked about where the two environments might have a similarity is Europa. You know, there's been talk about.
That's right.
In case, of course, we don't know that there's actually an ocean under that.
Talking about ice
once they
cap.
find out that, once they verify that there is an ocean, you know, if they verify that there's an ocean under there, that's
It's exciting stuff. Thank you very much. Appreciate it.